If someone asked you to add all of the numbers extending from 1 to 99 inclusive in the absence of support from a calculator or employment of a spreadsheet application in under 30 seconds, would you be able to do it? This video will discuss the methodology involved in computing the sum of any sequence of numbers expanding by a factor of 1 unit in 4 simple steps. One might intuitively attempt to add the individual numbers in a sequential order, such as 1 plus 2 equals 3, 3 plus 3 equals 6, 6 plus 4 equals 10, and continue the aggregation process until one reaches a point at which one fails to recall the sum of the preceding sequence. However, an attempt to compute the sum of an extensive sequence of numbers will consume an extensive period of time and might result in either failure to conclude the summation process or in an error as a function of failure to maintain a correct record of the aggregate summation in one's memory. Other people may attempt to employ a mathematical formula that permits for the computation of the sum of an arithmetic sequence of numbers. However, memories of mathematical formulas may fade in the absence of frequent employment, and the computation of some mathematical equations might require extensive effort. An easier method of computing the sum of a sequence of numbers expanding from 1 to any number by a factor of 1 unit involves the use of the first number and the last number of the sequence and does not require expenditure of time on summation of individual numbers in the sequence or recollection of formulas. Let's progress to the initial step of our endeavor to computing the sum of the sequence of numbers extending from 1 to 99 inclusive in under 30 seconds. The initial step involves adding the first number and the last number of the sequence. The first number of the sequence is 1 and the last number of the sequence is 99. Hence, the sum of the first number and the last number of the sequence extending from 1 to 99 inclusive equates to 100. You may be curious as to the basis of the focus on and employment of only the first number and the last number of the sequence in our endeavor. The sum of the first number and the last number of the sequence will be equivalent to the sums of their corresponding advancing and preceding sequential numbers, respectively, up to the median number of the sequence. For example, 1 plus 99 equals 100, 2 plus 98 equals 100, and 3 plus 97 equals 100 as well. And the pattern continues until one reaches the median number of 50, which will also be equivalent to the average of the sequence of numbers and will be extremely important in computing the sum of the sequence of numbers. Consequently, performing any additional summations in addition to the computation of the sum of the first number and of the last number of the sequence is redundant. Now that we have confirmed that the sum of the first number and last number of the sequence is equivalent to the sums of their corresponding advancing and preceding sequential numbers, respectively, we may focus on determining the factor by which to multiply the sum of the first and last numbers of the sequence. The second step involves the identification of the average number of the sequence of numbers, which is equivalent to the median number of the sequence and may be derived from the computation of the average of the first number and the last number of the sequence. Hence, we will divide the sum of the first number and the last number of the sequence, which we computed in step 1, by a factor of 2 in order to obtain the average value of 50 for the sequence of numbers extending from 1 to 99 inclusive. The third step involves the multiplication of the sum of the first number and the last number of the sequence, which we computed in step 1, by the average number of the sequence, which we calculated in step 2. The product between 100 and 50 is 5,000. The last step requires the subtraction of the average of the sequence of numbers from the product we obtained in step 3 in order to attain the sum of the sequence of numbers extending from 1 to 99 inclusive. Subtracting the average of 50, which corresponds to the sequence in reference, from the product of 5,000 that we computed in step 3 yields the result of 4,950 for the sum of the sequence of numbers extending from 1 to 99 inclusive. The four-step methodology involved in rapidly computing the sum of the sequence of numbers extending from 1 to 99 inclusive may be applied for the efficient computation of the sum of any arithmetic sequence of numbers expanding by a factor of 1 unit in the absence of a calculator or a spreadsheet application. Let's review the four-step methodology involved in computing the sum of any sequence of numbers prior to applying it for the mental computation of the sum of the sequence of numbers extending from 1 to 99 inclusive in under 30 seconds. Step 1. Compute the sum of the first number and the last number of the sequence. Step 2. Compute the average between the first number and the last number of the sequence. Step 3. Multiply the sum obtained in step 1 by the average computed in step 2. Step 4 requires subtraction of the average of the sequence of numbers, which was computed in step 2, from the product obtained in step 3. Let's implement the four-step methodology in calculating the sum of the sequence of numbers extending from 1 to 99 inclusive in under 30 seconds. Step 1. Summation of the first number and the last number. 1 plus 99 equals 100. Step 2. The average of the first number and the last number. 100 divided by 2 equals 50. Step 3. The product between 100 and 50 is 5,000. Step 4. Subtracting 50 from 5,000 yields a total of 4,950. We successfully computed the sum of the sequence of numbers extending from 1 to 99 inclusive in under 30 seconds through 4 simple steps. If you found the content in this video to be informative, then please click on the like button below. Until our next encounter.